Today we're gonna learn some physics with the help of friends. Today we're gonna learn some physics, 'cause that's what family's all about. Physics is the way to go. Oh yeah. Let's learn some physics today. Physics is really fun. Oh yeah.
Hi, I'm Wyatt, and today I'm going to take you, the viewer, on a stroll into the counterintuitive world of physics. Today we're going to analyze 2D kinematics, but before we do that, we're going to need to cover the basics of physics in 1D kinematics. In 1D kinematics, you can analyze vertical motion or horizontal motion alone, allowing you to get a basic grasp on the concepts in physics that are involved in 2D kinematics. One of the most basic concepts in physics are scalar and vector quantities. Scalar quantities are quantities that involve only magnitude, while vector quantities involve magnitude and direction. Another thing that starts with V is velocity, which is a vector quantity. Not to be confused with speed, velocity is a measure of displacement divided by time, with the units meters per second. Acceleration, relating to velocity, is a measure of the change in velocity over time. Velocity can be constant, meaning that there's zero acceleration, or it can be changing with a positive or negative acceleration, which could mean a speed up or a slowdown based on the direction of the velocity at the beginning. Acceleration, positive or negative, can mean two different things. Basically, if a velocity is starting off positive, and it can have a negative or positive acceleration, two different things could happen. It could speed up or slow down. Basically, if an object is traveling upwards with a positive initial velocity, but is acted on by the force of gravity, that means that it will slow down because gravity has a negative acceleration. And then, after the object reaches its max height, it will begin to go down, and it will have a negative velocity that will speed up because the magnitude increases as the acceleration is also negative.
Howdy nerds. We move on to the 2D kinematics part. Now, motion involves two parts, an x velocity and a y velocity, which are independent of each other. A good way to visualize the independent nature of the x and y components of 2D kinematics is by using the ball example. In this example, two balls are being moved. One of them is being thrown horizontally, another one is just being dropped. Now the question is, which one do you think is going to hit the ground first? Now usually we'd all say that it'd just be the one that's dropped. That is incorrect. This goes back to the counterintuity of physics. Now, when I say that the x velocity and the y velocity are independent, that when they're in motion, they don't get affected by each other. So, and then whenever I throw it horizontally, the x velocity will always remain constant, just because there's nothing else there to change it otherwise. There's no horizontal gravity or anything like that. And when you're dropping the ball, the y component will have usually a zero initial velocity. However, there will always be gravity acting upon it, which is measured as negative 9.8 meters per second squared. And so what that does is that makes both of the balls in the example fall at the same rate. Now the one thrown horizontally will fall at a greater distance from you, but they'll both reach the ground at the same time.
So basically, to summarize, today we looked into the basics of physics, looking at acceleration, velocity, scalars, and vectors, and then we took it a step further to look at 2D motion and the independence between x components and y components of velocity. I hope you learned something or increased your knowledge of something you already knew. Sayonara.